So welcome back for the next case study session. Our speaker is already waiting. Rohit. Hi. Take some moments. Let me check. So where is he? Rohit, can you enter again? I think we lost you. You have to maybe... here.
Yeah.
Hi, how are you?
I'm good.
And where are you?
I am in Bangalore, India.
Okay, and what time is it?
It's 6:10 in the evening.
Okay,
Yeah.
that's okay.
Yeah.
But you had a long day, so
Yeah.
yeah.
So good to see you again. Last time we met in Munich.
Yeah. Now it's in Munich. It's about 20 to 2. Yeah, sorry, I was looking on the wrong number. Yeah. So I'm looking forward to your presentation. When we talked the first time, you told me you're planning to have a live demo. Is that right?
I was planning, but unfortunately, because of this COVID and all,
Yeah.
it was difficult for me to get hold of the guys who can go in the retail shop and do the demo.
Yeah.
So basically, we have to simulate certain situations so that people can understand. So what I have done is that I have taken few images and tried to showcase the various corner cases that we have taken care of.
But it would be a great live demo, live from India. That would be a premiere, the first time at the POR conference. Especially with this kind of product. Great. So, okay, let's start. Please share your screen and I will mute.
Okay. Is this visible?
Yep, we see your screen.
Okay. So can I start, or are we waiting for somebody?
Yes, start. Please.
Okay. Yeah. So hi, my name is Rohit, and I work as a senior data scientist in a company called Mobisi Technologies, Bangalore. And I'm going to share a case study that we did with Unilever a few months back to help them in improving their sales forecasting model for ice cream business. So basically, they were getting a lot of out of stock conditions, wherein the customer goes to the shop, but he is not able to find the particular ice cream he's looking for, and that was a quite a setback for their sales, and that is where they wanted us to come in and help them. So that the way I have organized this presentation is about 2 or 3 slides about what we do, and then what is the business problem that we try to solve, some approaches towards the solution, because there were certain failures also that we encountered. And then initially I plan to do a live demo, but because of the situation, I'm not able to do it live. But I have few photographs or images to explain the different scenarios that we covered, and then results and impact to the business, as in the Unilever business. So just a brief about what we do. Basically, we are into Salesforce automation. To understand what is Salesforce, I'll just give you a very high level overview of how it happens in a normal scenario. Especially, it is very common in India. So a brand is there, say for example Unilever or P&G. They have their salesman. He will go to a retail shop and ask for what the shop wants, the outlet wants, and he will take a physical order, how many units of shampoo they want, how many units of soap they want, and all those. Then it is handed over to a distributor. The distributor will check the inventory, and based on the inventory situation, he will deliver the order. Now, this entire process takes some 2 or 3 days. What we do is that we try to automate or digitize certain portions of it. Basically, we have an app through which a person, the salesman takes the same order, and as soon as the order is taken, the order is sent to the distributor, and he can automatically check the inventory and ship the order. This entire thing now takes like less than a day, so as to say. So basically, all these physical steps have been changed. So this is what Bizom. So our company is Mobisi, and Bizom is the product, the flagship product of Bizom, of Mobisi. So, yeah. And we serve around 5 million outlets in India, and basically brands use our app to serve those many outlets. So we have like 500 plus brands on our platform. Now coming to the actual project that we did, Unilever as an ice cream business, the Walls, the Cornetto ice cream, they lose around 10% of their sales because of the out of stock situation. By out of stock, I mean to say, if you see the image on the right hand side, these baskets are the Cornetto ice cream baskets, and one of the basket, the red, the marked as red color, has only one Cornetto or maybe no Cornetto left. This is the situation of an out of stock, and this is what they don't want to have, because they are using some kind of a sales prediction model which says that these many number of Cornetto should be sufficient before the next replenishment happens, and obviously their model is failing. The major issue is that these traditional models don't take into account the out of stock events. There is no way how you can take this event into account, because the salesmen don't go every day to the shop, and the outlets or the shopkeeper has no interest in reporting these events to the Unilever as such. So that is where we come into picture, and our basically motive was to enhance their sales forecasting event algorithm by incorporating these OOS events. So one of the major part of our exercise or the project work was to identify these events, the out of stock events. The sales prediction more or less was as per Unilever model only. We did was added this OOS event in the entire model, and try to give a more realistic prediction to it. So that's why in my talk I will try to cover the detection of these events more, and the sales prediction I will cover in a later part of the presentation. And that is where the novelty of the entire project comes into, because the approach that we used was quite different. Now the baskets or these ice cream, the small containers are called baskets, and they can be either full or partially full or out of stock. The idea is to capture the various stages of these baskets, and then come up with some kind of a prediction. One constraint that was given to us was that you cannot change anything in the basket, as in like we cannot add any markers over here. So let me just use a pen to say. So sometimes what happens is that you can have these kind of a red color tapes which will say that you are below this point, and hence there is a out of stock. You take a photo and it is easier to figure out that there is a out of stock situation. But the problem is that Unilever has a huge install base, or the fridges are already out in the market. They can't change their fridge configuration because it's a massive task for them. So they didn't want that, and it should be. And the other thing was that whatever solution we give, it should be scalable to their fridge install base. One simplification that we did was that we cannot tell what is below this basket. So if you see this picture, this is the top shelf, and if you just remove the baskets on the top, you will find certain stock which is kept underneath. By taking an image of the entire fridge, we cannot tell what is beneath it. So that was the I will say the condition that we are not capturing here. So the entire focus is to take a photograph of this image of this fridge and tell what is the depth of this entire basket, and to figure out the out of stock situation. Now other related challenges were, or I will say unsaid challenges were, One is that we have to identify the SKUs or the variants of these ice creams pretty accurately. Because so if you see the bottom screen, there are like 5 variants of cornetto ice cream. And if suppose instead of saying vanilla ice cream, we say strawberry ice cream is out of stock, then their focus will be to replenish the strawberry ice cream. But the actual situation was that vanilla ice cream was not there. So the entire thing will go for a toss. So the accuracy is very important. The second is that the products are in the ice cream business, if you see, the products are quite similar to each other. It's very difficult. I mean, if you see the Magnum ice creams, all of them are like brown in color. The wrappers are brown in color, golden color, am written on top of it. So there are very few discriminative properties in a ice cream wrapper. The shapes are also very irregular. Like for example, cornetto is conical in shape, while there can be cups, there can be bars. So that is another difficulty in figuring out the ice cream. Then there are reflections of the glass, because you are taking a photo on the top from the top of the fridge. There will be frosting of the glass. There will be a reflection. So that is also there. Also, we have seen that if you take a photo in the daytime versus at the night time, the color scheme doesn't look same in the photograph that we capture. So that is also a problem. And there can be partially obstructed product, because the ice cream fridge is operated by the consumer. So he may not put the ice cream in the same place from where he picked up. So suppose he is looking for a strawberry cornetto. He's touching all the strawberry ice creams and then figuring out his cornetto. So he may leave the fridge in a little bit unorganized manner. So that is another problem. Some of the challenges that we faced were some technical challenges. For example, we didn't have much of experience in developing this depth analysis algorithm, how to find out the depth of the basket. And as I said, that accuracy is very important in this entire thing, because if you tell the wrong SKU or the wrong variant of the ice cream, then there is no point in basically taking any action by Unilever. Operational problems, as I said, that we need to capture a lot of images, and it is very difficult to collect the images from the real stores, the retail shops, because you have to every time go there, click the photos. Some of the times, or most of the times, people are hesitant to allow you to take camera and click their photographs and all. So it's a difficult task. And for a object detection kind of a problem, we need hundreds of images. And as I said, that there are many variants of a product, and the light conditions are also different. So we have to take like many images. And there was a very high time pressure. Only 3 months were allocated for this project, because based on our results, Unilever was supposed to pitch it in their main technical forum. It's a POC for them, whether an image-based solution can work to enhance their sales forecasting. So based on our results, they were going to convince their upper management and so on. So some of the approaches that we saw, there is a real sense camera, which is supposed to capture the depth of a object. And the way it does is that it gives a color scheme. The darker shades means that the things are at a greater depth, while the lighter shades are like it is on an upper depth. But the problem is that first of all, this camera is very expensive. It's like a $300 camera. Secondly, the accuracy of this depth analysis is not that great as far as the common literature that is available is concerned. So, and as accuracy was one of the main criteria for us, we could not go for it, because basically the cost was the major issue. Because if the cost is so high, then it cannot be scaled up. So then we used another approach, and so So apart from doing the Salesforce automation, we also do a lot of vision related things. That is mainly for the retail shops. So we do a lot of these object detection activities where we go and take photographs of a shelf and tell what products are there. And we have a product called as 35 Hawk, which does all that. So we thought of using the same platform and enhance it for a depth kind of an environment. So instead of taking a vertical shelf photograph and figuring out what is there, you take a horizontal shelf. So fridge can be considered as a horizontal shelf, and you take a photo of that fridge and figure out the things. Um, just to give a context of how the classification or is done for people who are not aware of. It's a very classic example of a problem called dog or cat. So given a image, you have to say whether it is a dog or it's a cat. The way you do is that you collect certain samples of both the objects, dogs and cats, and then you manually label, say, a few hundreds of them or thousands of them, depending on what kind of, what is the kind of image quality you have. And then you train a model, a neural network, and then you test with a new image. So you will give a new image and ask the model, what is it? This is what a general principle of a classification is. And we also try to use the same thing in a little different way. So what we said was that, so this is the image. If we try to just take or read this image as a basket which is full is one object, a basket which is partially full is another object, and basket which is empty or about to be empty is another object. So there are three classes, or dog, cat, and maybe mouse, so as to say. And all you have to do is that you train the model to figure out whether it is a cat or full basket, half basket, or a empty basket. And then the problem becomes a classification problem and can be solved in a much easier way. And a regular classification algorithms can help us to do that. And that is precisely what we did. And but there were challenges in doing it, and some of the challenges I'll just state. One challenge is that Unilever did not provide us any images, so we had to figure out a way of getting these images, and that is where I had earlier thought of giving a live demo of we collecting the real image from a retail shop and showing how the classification will happen on that image. So this is a kind of a camera setup we made. It's a very off-the-shelf kind of a hardware. I'll tell you about the hardware also. This camera is focused on the ice cream fridge, and all it takes the images, send it to our server, and there is a algorithm which is running which will classify those images. If it finds a signal which is or if it finds a low or a out of stock kind of a basket, it will raise a alarm. That is what happens. So just to give you a sense of what we have done is that there is a web camera, there is a Pi board, and there is a router, 4G router, so that it can transmit. And then we have a cloud infrastructure in our office, and that's all. So the entire setup cost as of now is less than $100. It can further come down because we don't require like connectivity in all the cases. Once the model is fine-tuned and all those things, we can remove this 4G router and then just have a webcam and a Pi board, and that again can be reduced. So basically, the cost have come down to a level where it is an acceptable thing. This is just a blow up pictures of the same thing. This is how a typical store looks like in India. So what we do is that we take this image, and then we have an algorithm which will do two things. One is that it will identify the variant of the product, which is Oreo Cornetto, for example, and then it will tell us what is the stock level. So F means normal, L means low, P means partial. And the way we detect this is that If you see the mesh in the bottom of the basket, that means this basket is almost empty, because that's where you will start seeing the bottom of the basket. If you can just see these grid lines here, then it means that it is partially full. And if you don't see significantly these grid lines, then it is a normal kind of a scenario. So instead of putting a tape over here, we are using these meshes to figure out where it is, whether it is a low, normal, or a full stock. And one more thing, additionally, what we have done is called as a planogram compliance, where we also tell you whether, so these ice creams have a place in this entire fridge. A chocolate cornetto should be placed in this place. If it is not, that is also a problem with the for Unilever, because they expect the things to be in a proper way, because of their market research and all those things tells that this is the right way in which the cornettos should be kept, and customer is more um, can easily find your products. So planogram compliance is to figure out whether your products are correctly placed or not, and we use it in multiple ways. So I'll just go through some of the corner cases also, what we have taken care of. So if you see this particular picture, this particular cornetto ice cream is kept on top of other ice creams. This is a very common scenario. I think it can occur in any geography, because when the customer comes, he tries to figure out his product and then keeps the other products as it is and go away. And this can be detected by a planogram compliance module, because it will say that this ice cream should not be present here, and we can reject this image. Another common scenario where a person is actually putting his hand inside, and at that time we took an image. So we have to remove these images from our analysis. Sometimes on the top of the fridge, somebody has kept some product. Especially true in a smaller outlets. And then this is an important scenario where other products are kept inside the basket. So this is a blue color cornetto which is kept in the yellow color cornetto. We don't want to do these the analysis on top of it, because if we suggest that this basket is, say, out of stock, we don't know whether which variant was supposed to be here. Whether it is a blue color cornetto that went out of stock, or is it a yellow color cornetto. So we need to discount these heterogeneous mixture of baskets. So after all these things, the results that we got were little encouraging. So there are three steps, if I would say. One is the basket detection. So the first thing is that how do you even detect a basket? So as I said that we will take the cross section or these baskets as our objects, and then say whether this is a empty basket. So how do you figure out that this is a basket? So we had a model which can do that, and we could do like 98% with accuracy and identify whether it is full, partial, or empty basket. The other thing is that differentiate between the variants. So vanilla versus butterscotch. So it is like a 95% accuracy result, and then combine the two. So this is the real use case that tell us that there is a vanilla cornetto in a basket, and that basket is partially full. So that is like a 92% accuracy that we could get. Now comes the sales prediction model, and how do we use it? So, so we use many data points while creating the model, and I think most of the data points are pretty standard. Like for example, transactions. We take care of like 1 year, 2 year sales data, as much as the companies can give. Especially the smaller companies don't have that much of data in a digital format, so we don't get so much of data. But companies like Unilever has a lot of data, so there's no problem there. Schemes and discounts is an important factor in our model, because your sales or the shopkeeper. So these predictions are from a salesman point of view. How much order that salesman is going to give me. It's not from the customer point of view. It's from a salesman point of view. So if you have a schemes and discount, the salesman is going to order more, because he is getting more stock for lesser amount of money. And whenever these kind of schemes and discounts are going on, we see a surge in the sales. Out of stock events, as I said, that we captured through the depth analysis algorithm. This was something which was missing earlier. Then there is the outlets, geolocation, and outlet category. So basically, geolocation is like sometimes you want to figure out which areas are more promising, or this set of outlet is different from another set of outlets. So correlation between different outlets can be figured out. Outlet category is an important factor, because depending on which type of outlet you are serving, the sales will be different. A medical store can also keep a ice cream, especially in India. So this is all from an Indian point of view. In India, medical store can keep a ice cream, but the sales of medical ice cream in medical store will be different, because I am not going to a medical store for a ice cream buying. I will go to a convenience store or a grocery or a Tesco kind of a store for an ice cream. So the sales will be different. The other factors are like footfall data. So if you are in a high footfall area, the sales will be high. Events, demographics also. If you are in a place where a lot of children or youngster are there, the ice cream sales will be higher. Also, the IT parks or the office space, the business districts will have a higher impact on the sales. And also we take the trend information, like is this outlet giving me the rising trend in the sales, or it is like a flat line or going down, those kind of things. So when we use all these data points, our R2 score is around 0.85. So a model is around 85% accurate. Now I just want to spend some time on this image or this picture. This blue color lines are the actual transactions or the actual sales that has happened from Unilever. The prediction, the orange color or the red color lines are the model that we trained on top of their data, and this is about it is following their ups and downs. The shape of the curves are almost coming to the point, but still after all that we are getting the out of stock situation. Now the green dotted line is the place where we have incorporated the out of stock events. So what our strategy is that the sales prediction is obviously failing because the out of stock situation is happening. So that means we need to boost the sales. If it was 100 units that we were predicting, or the Unilever was predicting, it has to be 100 plus some X percentage, which can keep that out of stock restricted. One important factor is that there is a weekly replenishment or a fortnightly replenishment that happens for ice cream stock. Now, our strategy is that to give a boost such that they can last the stock till the next replenishment happens. So, in concrete terms, if suppose your out of stock happens 2 days prior to your replenishment day, then we are going to boost the sales by say X%. If it happens like 3 days prior to your replenishment day, we are going to boost your sales by X plus Y%. And this is what we are going to learn through the model, that what percentage makes sense. And subsequently, those out of stock situations will go away. So initially, the out of stock situation will happen because we may not have given the right boost. But over a period of time, like 2 or 3 attempts, the percentages will be learned and the stock will be okay. So this is what we did with the suggested ordering part. And these are the two stores that we installed the solution. This is the lower store is a little bigger store, so there are two cameras. The fridge is also big, so one camera is focused on left hand side, the other camera is focused on the right hand side, and the upper store has a smaller fridge. Only one camera is good enough to capture the thing. So we installed in two retail shops, and we were able to capture the out of stock events during December to March, and enhance the the sales algorithm. And the stock out was reduced by 80%. So only 20% was the things that we could not figure out. And this experiment could not go further. Two reasons. One was COVID happened, because we thought of continuing this experiment anyways, because it helped us to not only cover the ice cream business, but any frozen food business where it has a horizontal fridge, and the main focus is to make sure that the stock is always there in the fridge. So any such kind of a product which has this kind of a fridge, we can do this analysis. So that's where we wanted to continue this, but because of COVID, we could not continue, because one of the shop actually got shut down for a few months. And key takeaway for us was that out of stock event plays an important role in fine tuning the sales prediction. And you can use the regular object detection and the classification algorithms to do the depth analysis also. You don't require a sophisticated sensing cameras. And yeah, because of these cameras, we could do a real-time monitoring also. So even though Unilever requirement was to do like a once in a day kind of a reporting, but we can do a real-time thing. So imagine a case that you have a fridge, and this was actually one of the use case that they were covering up, that standalone fridges where the shop is not very much interested in selling, but it is just giving the infrastructure so that the fridge can get a power and all. There is a camera, and it does a edge computing. As soon as there is a planogram non-compliance, the event gets raised. As soon as the stock is out of stock, the event gets raised, and just-in-time kind of a replenishment can happen. So those were the some takeaways from the project, and happy to take some question answers if there are any. And by the way, the top thing is about how we actually achieved all this, because when we were doing experiments with ice cream, we can't have ice cream as a product in our office. So we found a similar thing, a proxy of ice cream, which is like a biscuit, Oreo biscuit and Bonvita biscuit. One is red color, one is blue color, and we bought these baskets and tried to figure out whether we can do this analysis or not. So this is how we took it from lab to the production. Yeah, happy to take any questions.
All right, thank you very much. Impressive work. There are already two questions. Could you please stop sharing your screen? So
yeah,
great. So one question is by Sven, the speaker before. A nice application. Can you also already detect cross-products effects? For example, one Cornetto goes out of stock and the other flavor of Cornetto increases as a result. Then you could estimate out of stock and substitution effects.
Yes. So there is something called as a PP or trade promotion analysis that we do, where we do these kind of effect understanding, like if a product is there and suppose there is a 500 ml bottle and there is a 300 ml bottle, and you give a discount on 500 ml bottle, are you really making any money or you are losing out? So these kind of I will say the substitution effect, as you have said, we have that kind of analysis already there. For this project, we didn't do, but yes, we already have that thing in our product road portfolio.
And by the way, maybe I missed it, but why do you decide for ice cream? I mean, there's so many product categories, but is ice cream really the most critical thing, or is it the revenue driver?
No, it just came from a Unilever point of view. So we were basically doing a project for them. It's not that we had a choice there. They
Okay.
came with us, and now we are coming up with the choices for us, saying that we can do it for frozen food, we can do it for say confectionery, anything which can be kept in a this kind of a fridges and do the analysis.
That will be also my next question. So, for what other product categories are you now
Yeah.
adapting this method? Yeah. Okay.
Yes.
Okay, so Justin asks, thank you so much, Rohit. Stock out is also a very important concept in print retail sales. Is there a threshold you use to determine which shop receives such camera? If yes, how is it determined? If no, will you just roll out to all the shops?
Yeah. So the idea is that this camera will go away. It will be the salesman itself. So let me just go back to the first few slides. Maybe do I have to share again, or it is already shared? Is it shared? Can you see my screen?
Yeah.
Okay. So let me just go to the first slide. Sorry for so many animation. Okay. So see, as I said, that there is a salesman who goes to the outlet, and then he has the app-based solution, and he takes the order and punch it. So he can also take the photograph of that fridge. Okay. As I said, that Unilever is not interested in a very I would say like a real-time kind of an analysis, but even if the analysis happens after in a 1 day or so, it is okay for them. So the threshold is that so the camera was set up just for the collection of the data. If the data was readily available to us from Unilever point of view, we would have removed the camera altogether and just work with the images. But since the images were not available, we had to install that camera and then figure out a way of doing it. Also, it helped us to make a very strong case to Unilever that a regular camera can be used to satisfy this image analysis. So it helped us in that way. But there is no such kind of a thing that we have to have that camera there.
Okay. And can you show the camera again, please? I mean,
yeah, sure.
This is not an ordinary webcam. So you used, I think, Raspberry Pi.
Yes. So
can you explain why? So why did you not just only use a webcam, or?
Yeah. So see, the idea was that we could have used the webcam also. That was perfectly okay for us. The reason we used Pi board was see, we were capturing the images at a very high frequency, like every 2 minutes, 3 minutes, we were capturing the images. And some of the images, as I showed, were not of much interest, like the person putting a hand in the basket, or maybe the light is not good. Certain things can be like discarded at the source itself. That was one reason. The second reason was that we also wanted to try out this edge analytics. That tomorrow, if we want to basically send some kind of a notification, like the planogram is not correct, please change it. As I said, that the next level of automation is standalone fridges, and a person just goes and pick up the thing and go away. So in those cases, the Pi computer or any embedded computer would have will solve the purpose. So that's the point of putting this Pi board, but there was no. And this web camera is a regular camera. We used a Pi camera actually. There is a Pi board Pi camera also. Initially, we had used a Logitech web camera, but then we saw that Pi camera was also good enough. So,
okay, interesting. So okay, we're running out of time.
Sure.
Thank you very much again. Good luck with with continuing this project, like to see an update on your project maybe next year when you do this for other categories, and when we have even more data and also after Corona. This would be interesting how the consumer behavior changes. And so yes, thank you very much, and have a good evening.
Yeah, thanks a lot for listening to my talk. Thanks.
Bye.